Hi, chemistry students. This is your Unit 9 lesson on balancing chemical equations. You may have some guided notes. If you do, please use them. If you don't, this would be a good thing to do. Take some notes as I go through these examples. So balancing chemical equations is based on the law of conservation of matter, sometimes called conservation of mass. And it says in a chemical reaction, matter can be neither created nor destroyed, and this means the number and type of atoms does not change during a chemical reaction. Atoms are just rearranged. So we use equations to represent chemical reactions. And as we learned in previous units, the reactants go on the left side of the arrow, and they are the starting ingredients, just like the starting ingredients you might have to make a cake. And then the arrow is the actual chemical change, the combining and the rearranging. And then the products are the final product, like the eggs and the sugar and the flour that you used were the reactants, and the cake would be your product. Equations represent the reactants and products of a chemical change. Now, as we're going through balancing chemical equations to represent reactions, we have to be sure that we understand two terms and we don't get them confused. And those terms are coefficient and subscript. And coefficients are what we use to actually balance, look at the right ratio between reactants and the kinds of products that we get within a chemical reaction. Subscripts are telling us the ratio within a formula itself. So for example, in this particular example, we have the formula H2O. Everybody's pretty familiar with that. That's water. Here is one water molecule. It says that the ratio between the hydrogen atoms and the oxygen atoms that are covalently bonded to each other is 2:1. Two hydrogens bonded to one oxygen. So this is one molecule of water. Now the 3 and the subscript represents that ratio. Notice we don't have a 1, just to remind you. We usually don't write 1s as either coefficients or subscripts. The symbol itself sort of stands for 1. So we have 2 hydrogen atoms and 1 oxygen atom in each unit of H2O. Now the coefficient in front is what we actually use for balancing, and it just represents how many of these particular formulas, how many of these particular molecules we have. So if we have 3 H2O, that means that we essentially have 3 separate water molecules. So a lot of times students ask, does the 3 distribute? If you can sort of visualize what 3 H2O means, it means 3 oxygen molecules, then you can see that it would distribute, that within these 3 oxygen molecules, if we were to count up all the hydrogen, we'd have 3 times 2, or 1, 2, 3, 4, 5, 6 hydrogen atoms. And again, we have the oxygen, so that's 3 times 1, or 1, 2, 3 oxygen atoms. So that's how a coefficient, what it does to a formula, but we are never going to be changing subscripts when we're balancing equations. Never, never, never. All right, so at the beginning of this assignment, if you looked at my Canvas course, there was a video for you to watch, and it was a video of the sort of a historical video of the Army getting rid of sodium metal. And they were rolling barrels full of sodium metal into a lake, and you saw a huge explosion, a lot of steam, a lot of smoke. And the reaction that was actually going on there was sodium metal, which is a solid. That's what the S means. That's the state. This thing in parentheses is the state, plus the water, the pond water, and this is an L for liquid, not an I, an L. And those things combine, rearrange themselves to make the compound sodium hydroxide, ionic compound. However, it's a soluble or an ionic compound that dissociates and dissolves, so that's what the AQ stands for. It means that the sodium hydroxide that's formed is actually dissolved or dissociated in the water, and hydrogen gas. And that's what the G is. And hydrogen, remember, as an element is a diatomic, so hydrogen gas is H2. And a whole bunch of energy is released, and that energy actually ignites the hydrogen. And that's what you saw with the explosion. Now, I call this kind of equation a skeleton equation. It's scary because it's not balanced. It shows matter being created or destroyed, which we know is against the law of the conservation of matter or mass. And so one way to do sort of beginning is to be sure that you add up reactant atoms and products atoms, and then we're going to add coefficients to see what we need to do in order to balance it, to find the right ratio. As it's written now, it looks like 1 sodium reacts with 1 water to give us 1 NaOH plus 1 hydrogen. That might not be the right ratio, okay? And that's what we're going to use with coefficient. So essentially, first thing we will do is add up what we have. You'll see that on the reactant side, we have 1 sodium, we have 2 hydrogen, and 1 oxygen. Great. On the product side, though, we have 1 sodium. Now, hydrogen is in 2 different places. We have 1 here and 2 in this molecule here. So we actually have 3 hydrogen atoms. So we somehow created matter in this ratio. So we know that's not a legal balanced equation. The oxygen is balanced, but somehow we have to balance the hydrogen. So again, I'm going to show you that we're going to put lines in front here to help us balance, because we're not going to change H2O to H3O because that's not water, and we need to just balance. So this is a little bit like a puzzle. You need to kind of go back and forth and make adjustments. So let me see if I can get my marker here, get a good pen color. Let's do black, okay? And so let's go back and forth. We've got to have more hydrogen. So the only thing I can do is add another hydrogen here. Now that's going to give me 4 hydrogen. Now it's still not balanced, okay? So I need to go back, we're going back and forth to this side of the equation to see if we can get it balanced. So that gives me 4 hydrogen. Now if I put a 2 here, that's going to get me 5, and I'm going back and forth forever. But if I put a 2 here, that gives me 2 hydrogens here and 2 hydrogens here, and look, I got it balanced. Now, unfortunately, I've unbalanced a couple of other things possibly. So I put a 2 in front of NaOH, so that means I have 2 sodium over here. So that means I'm going to have to put a 2 over here. Again, this is just kind of a back and forth. So that means now that I have 2 sodium and 2 sodium. Okay, and now let's just check. So these are balanced. Let's check the oxygen. Well, now I've got 2 oxygen on this side. 2 times 0. But look, it worked out. I have 2 hydroxide on this side. So now all the numbers equal. And now I know the ratio is it's not 1 sodium hitting 1 water, but it's 2 sodiums hitting 2 waters to rearrange themselves to give me 2 sodium hydroxides. And again, this would be a 1, but we usually don't write that 1 in when we balance the equation. But you can do that sort of just to make sure the count is right. So this is how it would look balanced after we balanced it. We've got 2 sodium, 2 times 2, 4 hydrogen, 2 oxygen. And on this side, we have 2 sodium, 2 oxygen, and here's 2 hydrogen, and another 2 hydrogen give us 4. So this is our balanced equation, and we used coefficients. We did not change subscripts. It'd be so much easier if we just could change subscripts, but we're not going to, because water is not H3O, it's H2O. Okay, let's look at one more example before I get you to try. All right, again, if you watched the video at the beginning of the assignment, you saw Steve Spangler exploding a hydrogen balloon. And essentially what he was doing was taking hydrogen gas that was in the balloon, exposing it to just a tiny bit of heat to break some bonds, and the oxygen in the air inflamed it. It was a reaction between hydrogen and oxygen, and believe it or not, the actual product was water. Now, hydrogen and oxygen are both gases. Water, in this circumstance, in this particular example, would have been a gas. It was so hot, you saw the flame, and there was a great deal of energy. And again, a release of energy is something called an exothermic reaction, and we're going to talk about that more later in our unit. But again, the idea is you're looking at the before and the after. So let's look at the before here. We've got 2 hydrogens on this side, and we've got 2 oxygens on this side. But on the product side, we've got 2 hydrogens, so that's cool, but we only have 1 oxygen. So clearly, we're going to have to do some balancing. And again, the lines here, this is the skeleton. It's scary. It's not balanced, all right? So we're going to try to balance it. Now we have to have more oxygen. So the only thing we can do is we're not going to put a 2 down here, not going to add a subscript. That would be wrong. That would give us hydrogen peroxide, actually H2O2, and that's not what was formed. Water was formed. So we have to put a 2 in front, and that gives us 2 oxygens now. Okay, so this is going to change to a 2, but it disrupts our hydrogen. We now have on this side 4 hydrogen. Now, how are we going to fix that? Well, that's really pretty easy. We're just going to put a 2 here. Okay, and of course, this would be a 1. And let's just double check ourselves. That gives us 4 hydrogen. 4 hydrogen. My pen going here. And this side, and gives us 4 hydrogen on this side. And let's see, 2 oxygen on the reactants. And 2 times 1 is 2, so we got it balanced. And again, the idea here is instead of being 1 hydrogen hitting 1 oxygen, you got to get 2 hydrogens to hit the 2 oxygens. Think of it as like the oxygen breaks apart, okay? And then each hydrogen breaks apart and they reform bonds to make 2 water. So that they're just rearranging their bonds to make a new product, okay? So again, here's the before and after. And, we're going to put to balance it, we would be putting the 2 here and the 2 here and the 1 here, okay? All right, so let's have you try a couple. Here are a couple of equations that if you have your notes, you're going to balance. The first one is something called a single replacement reaction, and the second is something called a double replacement reaction, which we're going to be learning about. So let's start with this single replacement reaction. You can see what happens. The magnesium actually goes into the compound and the hydrogen gets kicked out. So here is the scary skeleton. You might want to pause the video and see if you can balance it yourself, and then we will go through it. All right, so if you have unpaused the video and tried it yourself, let's sort of look at the balance. We've got 1 magnesium here and 1 magnesium here, so that's balanced. But we've got 1 hydrogen here and 2 hydrogen here, so that suggests we should put a 2 here. Now, that's going to affect the chlorine. So 2 hydrogen and 2 chlorine on this side, but look, we have 2 chlorine on this side already. So it works out. So let's just put our 1s here for now, although we don't usually write it that way at the end. And let's just double check. We got 1 magnesium, 2 hydrogen, 2 hydrogen, 2 chlorines, that's a Cl, chlorine, and 2 chlorines. So this should be balanced. So it's 1 magnesium hitting 2 HCl is hydrochloric acid, 2 hydrochloric acids to form 1 magnesium chloride, which is dissolved, and you would probably with this reaction see some bubbles because it gives off hydrogen gas. All right, so again, here is the balance. And again, usually we do not show the 1s, okay? So if we were to write this, we would usually not put the 1s in front when we finished, okay? We would put the coefficients that were more than 1. Okay, there's HCl. And then we've got, whoops. Like my handwriting is worse than usual when you're trying to write with your finger, right? So again, we would tend, when we were to write this out, is once we had balanced it, we would take out all the 1s because we just assume 1s. But things are balanced. Okay, let's look at this one. Now this is something called a double replacement reaction. And what that means is we have 2 compounds that essentially switch partners. Ag is silver, and C and calcium. And so you can see that the Ag in the products, the silver chloride, the silver combines with the chlorine, and the calcium combines with the nitrate. Now always remember when you're doing double replacements that the cation always goes in the front. So When you're balancing a double replacement, oftentimes you will have a polyatomic ion, and it is much easier to treat this as a unit, like how many nitrates do I have, than to balance the nitrogen and the oxygen separately. It's just easier. So when we're sort of tallying up reactant atoms, we put nitrate ion, which is NO3 1-, silver ion, which is a 1+, which you've either memorized or you can see from the context of the equation. In this skeleton equation, we assume that the formulas are correct, okay? So you're not going to change the formulas. You can see that calcium chloride is the correct formula because calcium's a 2+ and chlorine's a 2-. And actually on the reactant side, we have 2 of these, right? So we've got 1 nitrate, 1 silver, and 2 chlorides ions and 1 calcium ion. Now on the product side, we've got actually 2 nitrates. Okay, that's what that parentheses 2 is. We've got 1, and we've got 1 of everything else. So we got to figure out a way to balance this. So let's start with the nitrate. Like I said, treat the nitrate like a thing. So we've got 2 nitrates on this side. Now I can't put in subscripts. I'm not going to put a parentheses and put a subscript because this is the right formula for silver nitrate. But I can put a coefficient in front. And that does change this now to having 2 nitrates. But it also changes the silver. I now have 2 silvers. So again, with these things, I sort of go back and forth and back and forth. I got 2 silvers. How am I going to balance it against the 1 silver? Well, I'm going to have to put a coefficient here. And that's going to now give me the 2 silvers. Yay, I'm balanced. Now let's go down to chlorine. On this side we have 2. And now that I put the coefficient here, isn't that nice how that works out? I've got 2 chlorines on this side. And let's just double check the calcium. Well, I had 1 before and I have 1 after. And I have finished balancing the equation. Notice that I don't put 1s in here because we just assume that they are 1. So again, this is what it would look like, but in the final version, once you have totally balanced it, we tend not to put in the coefficient of 1 in the final reaction. And so that is your lesson on balancing chemical equations. You'll have some practice. You're going to have lots of practice. So just sort of treat it as a puzzle and a game, and it's actually quite a lot of fun.